Have you ever encountered a situation in which after buying some clothes, paying them, and leaving the store, the alarm gets activated as if you're stealing those clothes? The reason for that, it has to do with the following technology, which is called RFID, or Radio Frequency Identification. And in this module, we are going to see how this technology is highly used within the realm of supply chain management. So let us start. What is RFID? RFID stands for Radio Frequency Identification. It's basically a method of tracking by using radio waves. So we have a combination of technologies that involves also chips, and those are the ones that are embedded on your clothes, and also readers that can get activated and perform like an alarm system or an opening door. So RFID, as said, is highly used in supply chain. This is just an example of it. This is an Airbox 350 in which 1.5 million components are tracked perfectly, real time, in the supply chain. Yeah, so RFID brings a lot of transparency and visibility. It helps supply chains to be reactive and responsive. So just to show you in a full cycle, here we have an example of Walmart and Pampers. I don't know if you're familiar with the Pampers diapers, in which a special promotion creates choppers to snap up boxes of Pampers. Think about toilet papers nowadays. This could also be the case. Each box of Pampers has an RFID tag. And that's, I think that is the difference between Pampers and toilet paper nowadays. Shelf-mounted scanners alert the stockroom of urgent need for restock. And that happens within Walmart. Meanwhile, Walmart's inventory management system tracks and links in-store stock and its warehouse stock, prompting quicker replenishment and providing accurate real-time data. So here we have a pull effect from the warehouses, the distribution centers, not pushing goods, but more like replenishing goods that are demanded on demand. Walmart systems are linked to the Procter & Gamble supply chain management system. So now it's with the supplier. Remember we talked about all this, how all these ERP systems are interconnected. So here, Walmart is in contact with Procter & Gamble, and the demand spikes reported by RFID tags are immediately visible through the supply chain. Procter & Gamble's logistics software tracks its trucks with GPS locators and tracks their contents with RFID tag readers. Regional managers can reroute trucks to fill urgent needs. So here we have some kind of, we talk also about that, a control tower. And then on real time, these kind of decisions are taken by people so that it can act right on the spot. So Procter & Gamble suppliers also use RFID tags and readers on their raw materials, giving Procter & Gamble visibility several tiers down the supply chain. So now we are talking about the suppliers of the suppliers and the suppliers. So everybody's having this ability of forecasting demand and reacting as is needed. Okay, so the components of the RFID system are the following. We have on one side tags, readers, software applications, and enterprise systems. So tags, very quickly, they come in all sort of forms, shapes. Some are flexible, some are hard, more like bricks. Readers, same story, all sort of shapes, scanners, arcs, gates, devices. Applications, well, there are a lot of softwares out there which are connected to ERP systems. And this is just an example, a list of applications that can go from aircraft, automotive, patient tracking, asset tracking. So you see hospitals are using that, manufacturing are also using that, even animal tracking. Okay, so here's a closer look how it works. So you have these tags, very often they are printed. Yeah, so on the one side you have the tags, the transponders, and as we are going to see later on, these tags can be active or passive because sometimes they can transmit, so they can communicate back and forth, or just one way. So in any case, that explains these arrows between the transponders, which are the tags, and the RFID readers. So there might be, of course, an exchange of data, but also other exchanges, such as energy and information like time. So RFID readers collect data, and the data goes to the application and can be interpreted, analyzed, and reported. So tags can be attached to almost anything. You see here pallets, cars, also living things, pets, livestock. There might be some regulations from country to country because of these are living organisms, and some could be that they don't like people putting tags on the color of a dog, but these things exist also for electronics, computers, TV, etc. So highly applicable. And as said, they come in two flavors, active and passive, and the difference is that active tags transmit radio signals, and they are also battery powered, whereas passive only reflects the radio, and the reader is the one that is powered. You see, like that scanner is the one that powers the RFID. The passive doesn't have any kind of battery. The ranges are also very different, where active can be at 300 feet and the other one is just very near, like 4 inches. Think about an RFID card. Maybe you have been to Via Piano, for example, a restaurant, and that is an RFID tag, or in offices to open doors, RFID tags. So you have many of these cards which are basically RFID, but they are passive RFIDs. So you can also categorize RFID tags by means of memory, frequency, physical dimensions, and of course the pricing. And they all might look like this. So you have from the relative cheap ones, 50 cents of a dollar, very flexible. Books in libraries might have that. And of course, more complex ones which are hard, they get actually screwed to something, to a pallet, and they have different characteristics, dimensions, reachability, etc. So they have different characteristics. So readers, same story. The readers, also known as interrogators, can be at a fixed point. Here, fixed point. So a forklift is driving through, and then the reader scans what the forklift is carrying. So they can be at the entrance or an exit, you know, when you are loading a truck. Point of sale and a warehouse. Readers can also be mobile, tether, handheld. So you can also have handheld devices that, just like barcode scanners, you can also read the RFIDs. And wireless. So let's just have a closer look. For instance, these are all conveyors. So the main idea is that goods are flowing through the conveyor, and then you have a fixed position reader, interrogator, scanning all the items that are flowing. You can also have it in this, there are products like this one. You have a reader, so it's more like a tunnel. So, and the capacity is measured, well, by the speed at which the conveyor can go through, or sometimes the length of the tunnel, so that you can process a certain number of items per time. So it can be measured, capacity gets measured as a rate, units, time. So handheld applications might look like everything you see here, which is not exactly the same. You see, this is purely wireless, and here is more like attached to a certain device. And here you have a fixed station. So all in all, you can read units, but also you can also read batches. So a combination of all these units. So typical questions they help you to answer is, well, what is here? What is inside of this box? Where is it going? So this information is stored inside the RFID. Where has it been? So the RFID can store that update, the timestamps, for example, of the stage of where they are located in a specific pipeline. So this information gets stored. And then you can say, well, should this item be here? Maybe it should be already way ahead and it's already delayed. You can also have information of what have I assembled or disassembled? How many do I have? Do I have enough? So quantity related items. information of status, like has this been repaired, is this under guarantee, is this complete. So again, RFID see it as a more sophisticated barcode system or even QR code system. You can simply store way more information. So if you are transporting perishables, you might have the due date in which the milk or the yogurt will be due. So you can have it also there. And then as these products are flowing through the supply chain, you have readers. And in the case you are already having a milk that is very old, then the reader might detect that. And then it can signal that, hey, this item shouldn't be here. And that is taken away. Same story with lots. When you have batches or lots that are damaged by some kind of reason, then you can quickly identify those lots. You know, as I'm talking, it came to my mind an incident. I think it happened at McDonald's or Burger King. I'm not 100% sure, but I know that once there was an incident of contaminated meat. So, okay, again, it was tracked. This could be tracked, and then expulsed or taken out of the system, so to say. Okay, so you can have readers, fixed position, so for shipping. So here you have a rotating table with the plastic wraps, like those that you have seen maybe on airports. And then, you know, all the data gets registered from this pallet. And it might be that you have a combination of different products. Yeah? So you attach an RFID to the pallet, and this is a cluster of many products, and this pallet will end up going to a particular customer, so that the customer can receive it, also gets the information of what is inside, the status of this product, etc. So this is called aggregation. With respect to readers, well, they might look like these gates. So you have your fixed position, but now you really antennas everywhere, and pallets are flowing by means of forklifts, for example. So here are some pictures that will show you that. Here, that's a truck, by the way. That's a person, by the way. And then he's pulling the pallet and the scanners are reading. There even some kind of alarm system. So RFID portals can check an entire pallet. Yeah. And this is just an example of moving materials so that you know where specific items are located inside of a warehouse. And again, here is your arc, just like in that store in which you try to steal some clothes. No, I'm just kidding about that. Okay, so what's with these portal applications? Well, even though they are very versatile, there is a limited capacity, so there's a limited number of items, and the so-called forklift has also a limited speed. If you run too fast, it might be that the item doesn't get read. You might also have alarm systems. We saw in that other picture that there was like an alarm, some lights, and this can indicate if that item shouldn't be going there to the truck. So you have also this kind of assistance. Now, in the selection of RFID tags, there are many considerations. This is, by the way, a blood transfusion storage, and as you can imagine, this is a very cold room. So temperature is just among the different factors to be considered when selecting the appropriate RFID tags. RFID tags also have certain limitations, especially when transmitting through liquids, for instance. They don't work very well. And also angles of reading, etc. So the environment itself does play a role in the performance of RFID tags. Okay, so there's a regulation behind. So countries have regulate, because remember, these are radio waves and the spectrum is limited. So there is a need for regulations, and depending on the region, Europe, US, you have institutions that are in charge for that. So for example, in the US, you have the Federal Communications Commission, or also known as FCC. That is a key regulatory body, and they give you permission to use certain spectrum for certain uses of RFID. Okay, so without going too technical, just here is a spectrum. So basically, when an electron moves, they create electromagnetic waves that goes through the air. So these waves can pass through some physical objects, some even vacuum, so even without air. The number of oscillations per second of an electromagnetic wave, that's what we call frequency. And frequency is measured by, can you recognize that? I don't know if you have used radios like in the old time. So it's measured by hertz, and you have gigahertz, megahertz, kilohertz. So the distance between two consecutive wave peaks, that is what we call the wavelength. So if you would see these peaks, these are the valleys, and these are the peaks, this distance, that is a wavelength. And here you can see the connection of a short wave and a long wave. Here is, by the way, AM broadcast. I don't know if you have ever heard a radio AM. So AM is at a longer wavelength amplitude, modular amplitude, I think it's called. And then, of course, you have FM on a different spectrum, and TV as well, and microwave. So you see it goes from audio to radio, and then we go all the way to infrared. I mean, now our eyes cannot detect these low frequencies, although there are some animals that can actually do. I think shrimps can actually get to see some of this. Cats, probably, I don't know. They say that they can see in the night. So that could mean that they go beyond this. That is just the visible light for us, by the way. These are the colors that we get to see. But as you know, there is ultraviolet and there is even X-rays. They also fall into this spectrum. So in this spectrum, this is the range in which RFID is working, in which the data communication fluctuates. It's just this part. Of course, we cannot see it because what we can see is only here. The rest we cannot see. We might hear or not even that. Okay, so countries, there are some regions. Like once upon a time with DVD players, there were DVD players for different regions. So Europe used a region, North America, South America, they all use different regions. And I think the same for video games, at least used to be called like that. PAL system and North NTSF, I think it's called. So you have these standards, and here is the same. So there is an International Telecommunication Union, and they define what is a specific region. So all the American continent, that is region 2. Europe, where we are living, that's region 1, and that includes Middle East and Africa. And region 3 is basically Asia. So that is China, India, Japan, Korea, etc. So these are the 3 main regions. So nevertheless, although you might be within a region, countries also use certain specific spectrums. And this is just like a very long list. Don't worry, I'm not going to read all that. But here you can see how US and Canada, they work in between 902, 928 megahertz. Mexico as well, and Puerto Rico. But Brazil stops at 907. So no more 928. But if we go to North Africa, it's completely different. It's a completely different story. Now they are moving in the 800s. South Africa, Israel, it's a very tight spectrum. 915, 917, that's it. They don't go as far as, for example, the US. And here you can see the huge contrast. Turkey, the Arabs, Iran, etc. Here is Europe, by the way. And again, power changes country by country as well. Okay, so this is just the electromagnetic spectrum. And that's it with RFID. So RFID, nothing new about that technology, is everywhere. Chips are becoming cheaper and cheaper and cheaper. But here is something interesting to reflect. How come we don't get to see the use of RFID on supermarkets? How come we still rely on going through the cashier as usual, and there is this person scanning the barcodes, and where we could just simply go through an arc with our shopping cart and all the information should get registered? Isn't that interesting? That is an interesting question. There is an answer to that, but I won't give you that answer. That can be discussed on our assignment. With this, I say goodbye. This is the last module, module 12. Of course, there's so much more to see. We are just scrapping the surface of the technologies software and hardware that play a role in supply chain management. I hope that you enjoyed this course. I hope that you got something of value. It's a shame that we couldn't meet each other personally, and I'm here just talking to a computer and not talking to you in face to face. But hey, that's how life is. I wish you all the best, and well, stay healthy. Bye bye.